All right, welcome. So in this tutorial, our goal is to make a Starfield, and be able to like fly around and actually have these be full meshes. Uh, and let's zoom in. And sorry, it's twinkling a lot, but we're gonna fix all that. This is sort of the midway through progress. But as you can see, in this example, I'm using custom LODs. We're actually gonna skip that part and just do the automatic LODs, but maybe in a separate video I can go over how to make manual LODs, and LODs stand for level of detail. So how I sort of got involved in this is I was doing a course from GD Quest, and of course he does these excellent tutorials, and if you have the means, I highly recommend you follow one of his courses when you're first starting out, because they're great. But in this, I bought this like a long time ago, and it was like an early access, and there wasn't a whole lot of content. But he's since filled out more. But I had started kind of playing around with 3D, and but I still wanted to make sure I knew all the basics. And in his course, he makes a spaceship, and I thought that was kind of neat, but I kind of wanted to try it in 3D. And so, looking at this, I was like, all right, well, this is cool. How do I do this Starfield? I kind of wanted this like 3D Starfield, and I searched and I couldn't find much until I came across this video, which was great. So I just want to play you like a minute of this. I'll link in the description this video.
And 500,000.
But
you know what I'm saying?
he's
Now we got
basically
stars
gonna
way
create
out
this
there,
3D
but we're going to
Starfield.
have 7,500 of them. You know what I'm saying? 7,500 stars. No, we're going to do 12,000 stars. Okay, boom. Now we have a Starfield. And I just want to point out a couple things that we've done, even though this took a little bit of time. We got stars that obviously change color based off your distance, right? They change color based off the distance. They transcribe, and they're really good. The transitions are real nice, real nice. You know what I'm saying? But cooler than that, I just want to say cooler than that is all of these are meshes. They are balls, big balls, big purple, pink balls that you could actually add more code to if you needed them to blink or disappear or move.
So I think that's good. That kind of gives you a brief overview of the thing. I feel like after listening to him, I need some sort of intro, like wish I was Australian. It could be like, "G'day, g'day," or I could just use my native California LA accent and just be like, "What up, my good dudes?" All right, I'll just stick with this though. So, but anyways, this guy's great. You get called bruh a lot during the video, which is great. But how do we do this in Godot? So I had started out, and I'll be honest, I was using Unreal, I know, but I finally got a good graphics card, like I'd been on this 1660 Ti for forever, and then I got this new NVIDIA, and man, it has been nothing but a boondoggle. It's like super expensive, had to sell a kidney to get it, and just tons of driver issues, so I don't recommend it at this point in time. But anyways, it has allowed me to finally really run Unreal, and you can see you really can create this cool 3D Starfield and fly right past these meshes and stuff. And so using some blueprints, I managed to get the ship kind of going in this Starfield, which is really cool. So yeah, this is what we're going to try to do, but in Godot. I will say, don't tell anyone. There are some really nice things about Unreal when you're doing 3D stuff, like the blueprints are nice. You can, like, when you're making a material, it's like super nice. So I just want to show you what's out there when we get to Godot's visual shader to kind of make these stars the way he does. It's going to be a little bit rougher than this, just so you're saying. This is going to take me a little bit more time to go over in detail to construct this, but I'll try and go step by step so we can really understand what he accomplished and how we can make our own cool Starfield. All right. So, without further ado, let's give this a close. All right. Let's minimize that. So, where do we start? At the beginning. So, let us close you down. And that leaves us with our whiteboard. Okay. see. Pen, are you working? Oh, good. All right, so there's a few things we kind of need to do, and this is going to be the game plan. So one, we need a mesh. And then I think we're going to take a little side tangent into looking at LODs, which stand for level of detail. Just sort of how it's automatically produced for us, and perhaps, like I said, later we can do another video about how to create our own LODs. But for now, we'll just use the automatic ones, and hopefully it'll be performant enough. If it's not, then maybe we'll look at something else. All right, but once we have a mesh, we need to shade the mesh. So we need to give it like a nice shader that will do the same things and make the stars change colors as we get further away from them, just so we can kind of get feature parity. And then maybe we'll explore just doing a few early things like making some of them twinkle or that kind of thing. All right, and then the last thing is once we've got our mesh and once we've got our shader, then we have to put it all together, and we have to use code to instantiate it all and create our Starfield. All right, so that's the game plan. And so let's start with step one. We need a mesh. So where are we going to get a mesh? Well, we are going to get a mesh in Blender. So I have Blender installed under Steam, and I highly recommend it because it just keeps updating for you. Although I will say Godot, probably not the best choice to install via Steam, just because it keeps updating and your projects, updates of the engine might break things. I guess the same could be true of Blender, but I don't do anything that's fancy enough for that to be a problem. So I'm going to launch Blender, and I'm going to make it sizable so you guys can see it. And we're just going to start general. And here is our default cube, and we are going to get rid of our default cube. So here's the Blender interface. It's a little cumbersome to move around in, but you can see we have our 3D cursor here, and I'll just give you a few basics. But if you want a great Blender tutorial, and I'll link that below, that's Grant Abbott. He has some videos on gamedev.tv, and he really is just a fantastic Blender teacher, so I'll highly recommend that. But if you're getting into Blender, but we'll just do a basics. We just need a ball. We don't need anything fancy. And so you can see if I hold shift and right click, I can move this. This is the 3D cursor around. You might accidentally do that, and so I'll just show you the quick trick in moving it back, and that is shift C. So shift C will put it all back into place. All right, and now what we are going to do with the 3D cursor dead center in the world, we are going to come up here to the add menu, and we're going to go to add mesh, and we need a sphere. Now, this sphere comes with some parameters that we can tweak, and unfortunately you can only tweak it one time. So as soon as you make it, and the minute that this menu closes, you can never get it back. So if you mess up, you're just going to have to delete it and Shift A, or come up Shift A to add. So this is Shift A will open up the hotkey for the add menu, or you come back up here to mesh if you mess something up. So we'll just do that, and then we'll do a Shift A to add again, and we will do mesh and UV sphere. And here, down here, we can see we have like this this panel, and we can increase our segments, for example. So so you can just grab it and then slide it right, and you can see our sphere is changing. Let me actually zoom in a little bit so you can see that better. But as we change the segments, you can see it's getting more and more detailed. Now, how detailed? Well, that's a good question. So we're going to come up here, and we're going to come to our overlay, which is this little circle and circle button. And we're going to click it, and we're going to click on this button that says statistics. And that is going to show us how many triangles and faces and edges and vertices and all that stuff. So we're going to come back, and we're going to see our triangle count is starting to increase. Right now it's at 1,500, and I'm going to increase the rings. So the rings are like, so the segments are the longitude lines, right? So you can see, like, if we decrease them a lot, we'll see that there's only like 4 or 5 longitude lines, and the rings are the latitude lines. So the more we increase, the more smooth this becomes. See, if you go like hog wild, it really becomes quite smooth. But of course, we have a star that has 26,000 triangles, which is probably too much, especially when we're going to put a material on it that is going to glow. So we're gonna just move that right back down, and I think we're going to aim for a range of about 3. Let's do 2,500 triangles. So we'll just move these segments in so that we get about 2,500. So that's what I got, 35 and 38, good enough. And then the radius, so Blender and Godot both use 1 meter as the default unit. Of course, the sphere with a radius of 1 meter is going to be 2 meters, right? The diameter is 2 times the radius, so we want this to be 1 meter, so we have a unit ball. So I'm just going to put 0.5 for the radius, and now we have a 1 meter ball. And then we're just going to click away. Now you can do things like S to scale it, and then you kind of drag off. I'm going to hit escape because I don't want to do that. But let's say you do want to, shift it. The most important thing when you're importing stuff into Godot or that kind of thing is you have to apply any stuff you do, like rotations or scaling or any of that stuff. You need to apply it before you use it. And the way you apply it is Control A. Control A will you've selected, and then so make sure there's a yellow circle around it, and hit Control A, and that will apply rotation. So you can apply all transforms, and that'll apply everything so that it doesn't come in already kind of wonky and scaled, because that will make your life much more difficult. But I don't want to do that. I want my nice 1 meter ball, so I'm going to Control Z back down to my 1 meter ball. Okay. And you can see here under this menu that pops out, and there is a hotkey. Let's see, can't get it to go back in. All right, well, it's out. But if you want, the hotkey is N to move it. If you ever need it, you just click on that little tiny chevron right there, and that'll pop it up, and then you can see your transforms, and hit N to open and close it. N is in November. All right, so we can see we don't have any modifications to our location, any modifications to our rotation, and any modifications to our scale. So that's perfectly what we want. And so we are going to save this, and I'll show you something cool. So if we save this into our Godot projects, and so I don't have a Godot project, so let us make one of those. So let's open up our project manager, and we will hit create, and I am going to, you are going to be /dev Godot, and then we're going to call you Starfield tutorial. And this is frustrating. It doesn't create the path even when you have create folder. Oh, maybe if I use the slashes? Let's see. Will that do it? Nope. Alright, so it's not going to make that name, so we're just going to have to make that name. Starfield tutorial. Alright. And let's hit create. Tutorial. Okay. Create. And it's going to pop open, and we now have our project. And we're just going to click a 3D scene. Perfect. And now we have a 3D scene. Now we're going to go back to Blender. So we're going to just save all this, and let's give it a name. Let's call this node Starfield. And let us come back. And then let's save this, and we'll call it, I don't like the underscore naming, Starfield scene. Okay, so we've saved it, and now we are going to go back to Blender, and we are going to save it under, doesn't see it. Is there a refresh? There is refresh, and here we have our Starfield tutorial. Okay, and I'm going to save this as star.blend. All right, so let us hit this save button. I'm going to call it star.blend, and we're going to save. And now when we come to Godot, okay, so this, you might end up with this pop-up. You do need to give it the Blender executable path. Now mine, I believe, is in /games Steam dmaps common blender.exe. Alright, so let us confirm the path, and now we'll be able to import the files. And as you can see, we now have this star.blend in our file system. So let's go ahead and double click it, and we will open it up, and oh my goodness, it is blinding. Why is this looking like this? So the mesh... Alright, I know what happened. So if you see in our scene here, so let's move this over. If you see here in our scene, you can see there's a light and a camera, and that is because Blender by default in its scene has those saved, and we just need to get rid of them. But here's the cool part about working with Blender and Godot, take that Unreal, is we can come up here to this thing, and we can select the camera, hold shift, select light, and just hit delete, and they're gone. And now we'll save it. Control S to save, and we will come back to this, and it'll re-import it, and we will double click it. Oop, we will double click our star, and now, well, it's still a little on the bright side, but that's okay. We've gotten rid of at least of the other stuff, and it's not quite so glaring. Okay, so if you look at the scene that we have imported, you will see there is the scene, and there is this red box, and that is called a mesh instance, and you will see this star sphere, and that is the mesh itself. And we need to get that mesh out because we want to make our own mesh instance. We don't want to use this sphere here. We want to create our own because we're going to be instantiating them and doing all that stuff. So I need some way of extracting this mesh. But before we do that, let's just have a look here. So as you can see, we have these LODs, that just says default. You can have enable or disable, but we're going to leave it default. And we're going to just close here, and let's just pull one of these into our scene so we can kind of take a look at this. So we have our star, and we're just going to pop that in, that Blender file, and it, as you can see, it has made in the scene tree a new star node, which is its own scene. And of course you can open anyway, and then here's the star scene. You can of course import an inherited one. So here we have our nice round ball. And we need to make this, as he is a big, beautiful ball, we need to make it a star. And we are quite far from that still. So let us have at least a look and understand what the LODs are. And by default, if we look at our star blend, oh, you know what? Let's actually quickly go back in here and look at this. You can see there's these mesh instance, and there's layers and stuff like that, but we're just gonna leave that be. All right, so now let's go into the perspective here, and I'm gonna do two things. One, I'm going to turn on frame time so that we can see our FPS and how much we're gonna tank it, at least in the editor. And then I'm going to switch here from display normal to display wireframe. And this is going to show us how the LODs work. So as you can see right now, we have a nice sphere. It's got all of these triangles. You see how each of these quads have turned into a triangle, which is why people love quads and when they're making meshes, because quads are nicely dividable into triangles. So let's start moving away though. And as you can see, let's unselect it. As you can see, when we start to move out, all of a sudden this sphere looks like it hollowed out a little bit, right? We don't see quite as many of those things, and you can see the triangles. And this is a process called decimation. So decimation, you know, from French to remove 10% of, but obviously it's not quite 10%. But as you can see, the further we move back, we again have a decimation where as we move further back and then this object gets smaller, Godot is removing these triangles, and it might be a little bit hard for you to see on your end, but you can see all of them, some of them, way less. And as we get further away, you'll see another pop, maybe, yep, and see, you can now see more of the areas between it. So we're removing triangles. So that's Godot automatically created these meshes in the mesh array that are less detailed as we get further away. So it's kind of doing the work for us. But again, we can go over, making manual LODs, but maybe in a different video. But for now, we're just gonna use Godot's default LOD machine. All right. But I told you we need to extract this mesh so that we can kind of have control over the mesh instance, and we'll talk about what mesh instances are too in a minute. So first we need the mesh itself, and how do we get that? All right, so we need to go back to our star scene, and as you can see, we've got this mesh instance, which is the red one, and then this white one with a diagonal line, and that is the mesh itself. And we need to extract this, and fortunately Godot makes it pretty easy to do that. So I'm going to move this over here so we can see, so we can all see. Sorry, it's a little bit off screen, so apologies. I'm going to have to move this over, but I do have this mesh selected. Oh, maybe I can just make this smaller. Let's see if that works. Okay, there we go. So I'm going to come over here with the mesh selected and click Save to File, Enabled On. And I'm going to save this mesh. So I'm just going to leave it in the root directory, bad practice, but whatever, we're just doing a tutorial. So star mesh. And I'm going to hit Save. And that didn't save it yet. You do have to click re-import. See, as you can see in the file system, we don't have it yet. But I'm going to click re-import, and all of a sudden now we have this star mesh res. And if we double click it, we can see we have this array mesh. And what is that array? Remember, it's an array of the vertices and the LODs, so that it can go through as it picks LODs to begin the decimation process. The shadow mesh we are not going to get into. I still have to wrap my head around that, but for now, suffice it to say, we have got our mesh out. So let us delete this star scene and let us create our own mesh instance. And we are going to hit the plus, and we are going to search for mesh instance 3D. And we're going to hit enter, and we are created it, and we are going to call this star. And the mesh instance needs a mesh. So the mesh instance is really just holding transform information. It is not holding the mesh itself yet. The mesh itself is a resource, and the mesh instance is a node that contains the transform information for the mesh. And I'll show you what I mean by that. Okay, so oops. So you can actually just drag a mesh out into the world, but we don't want to do that. So we're gonna delete that, and we're going to click back on our star, and we are going to move the mesh all the way over here to the mesh property, and all of a sudden now our mesh instance, which is the star, now shows you that mesh. Now what's interesting about a mesh instance, right, is that it has this mesh data. What happens when we duplicate it? So let's create a few more stars, because we're going to need a lot of stars. So let's just move these around. So what we have now is we have 4 stars, and you can already see this one is decimated compared to these ones. So we have the decimation working still. So it's, even though we extracted the mesh, the LOD system is still going to be perfectly working, which is, good to know. Now we've got these mesh instances, and they're all using the same mesh resource. And why is that important? Each of these meshes is really just holding a transform. It might hold a material, it might hold a few other things, but it's really just holding the information of where and how to display the mesh, and not so much the mesh itself, which has a lot of data in it. And that's important because that means that the GPU can access just one area of memory and store that mesh, and then it can get instance all over the place in what's called in one draw call. And a draw call is just the GPU saying, the program telling the GPU, hey, please draw all of these. So there was a post by Kalanu confirming that actually mesh instancing and multi-meshes, which you might have heard of, you probably don't need to use multi-mesh unless you're really want to populate a surface with random stuff and make your life easier. But for just doing mesh instances, they're going to be almost as performant as using a multi-mesh. So for this case, for our case, where we're just going to be sprinkling, we're going to be creating our own random meshes all over the place, mesh instances, excuse me, all over the place, but using the same exact mesh, that is still going to just incur one GPU call. So that's the new thing with the Vulkan forward plus renderer, is you don't have to worry about all of these mesh instances creating separate objects in memory and doing that. But what's the downside to it? And the downside is that all of these mesh instances are using the exact same resource, this starmesh.res, and that one mesh resource is going to be stored on the GPU in one spot, and all of these mesh instances are really just holding different transforms and maybe some materials and maybe some unique features, but they're not storing the underlying resource, which of course, these are just circles, but you can imagine like trees which have tons of foliage on them and all that stuff. Those each would have to be, if they weren't instanced, they would all have to be each stored in a place in memory and then loaded individually, which requires multiple draw calls, right? You have to like, okay, well, this one changed and now we need to update it, and that one changed, and that is going to slow things down a lot. Whereas this can all be done in one. Now, what is the limitation of that? Well, the limitation of that is that each of these are just instances of this one resource. And that means that if we change this underlying resource, all of them will change. So how do we make them unique? Well, that's where shaders come in and shader magic. So if you really want to have each of these look unique, you're going to need a shader material that each one of them can be a little bit different. And so that's going to be step number 2. All right. Now I do want to show you that these mesh instances can have some other things, and we'll actually look at one thing called the level of detail. And so we're going to come into this mesh instance, which is on the first one, this top one here, geometry here, and this is where we can see this term called LOD bias. And LOD bias is going to be how aggressive the engine is about using these automatic LODs. And basically more than one means it's going to try and preserve details. So for instance, let's turn this up to like 3. So now let's look at this mesh compared to the others as we zoom out. So you can see these 3 have decimated, but this one has not. And that's because the bias is over 1, and so it's favoring high detail. Look, we've even come out here. These are decimated a second time, and this one has still preserved all its triangles. And only until we get about here do you see it's gone through its first decimation. Right about there, you can see it popping out of the same number of triangles. So that is going to try and preserve stuff. So if you have one object that you really want to keep nicely detailed in the distance, you can set that bias and it'll keep looking nicer as you go out, but at the cost of performance, right? But you can see we can set that individually on one. Now, alternatively, we can also turn down this LOD bias to like like 0.01, I guess is where that ended up. And look, it looks terrible until we get there, and even this close, it's still using a pretty decimated cube. But remember, these are stars. We might not want that LOD bias of 1, so we can futz with that parameter later. For now, I'm going to leave it at 1, but let's try 0.5 and just see how that's different. So we can see that's nice, but it's already lower compared to the others. Even when these are drawn, this is already 2 levels of decimation, or maybe it's just 1. Yeah, I guess it's just 1. But if we turn that down even more, let's say 0.2, now it's quite decimated even close up, and it's not until we get really close that it's perfect. But for our needs, that probably looks just fine. I mean, if we remember, we're going to have a material that's glowing, so it's going to really affect the geometry. So we can probably keep it. We can kind of remember that we just need the bias to be, because see, right at this range, this still looks pretty much like a circle, right? And even out here, it's all looking like a circle. So I think we're going to be fine if we set that LOD bias to 0.2, because that we probably had way too many triangles to begin with. Maybe we'll turn it down a little bit, because I guess when we're this close is here. Let me turn. So if you want to turn down the speed, you can hold down right mouse button and the scroll wheel down, and that'll reduce the speed at which you're traveling in the viewport. So that looks pretty good. I don't know. All right, maybe we'll remember that parameter. Okay. So the next thing we need to do is make these stars look like stars, because right now, I mean, even when we go back to normal, they just have this boring white material. So we need to do better than that. So on to part 2 is going to be shading these stars. And I think we'll roll that into a second video, because this one is already quite long.